Hello, beautiful people. Today we are studying 7.3 hypothesis testing for the mean when sigma is unknown. The standard deviation, the population standard deviation, that is not known. So our SWABAT is going to be define critical values in a t-distribution. We're going to use a t-test to test the mean, mu, when sigma is not known, and then we're also going to use technology to find p-values and use them when with a t-test to test a mean mu. I'm going to tell you, basically you're doing kind of the same thing that we did in the previous lesson for 7.2. In terms of technology, the only thing is we're going to be using z-scores instead of t-scores. So a couple things here. Nothing too new. We're going to identify the significance of A, the level of significance. We're going to identify the degrees of freedom, and then we are going to have some critical values, and you have your table already for this, but a couple things I want you to kind of just see. For a left tail test, we're going to be using just one tail for the alpha, and this is going to be the column with a negative sign. So graphically though, this is what you're thinking about for a left tail test. It's going to be a negative t, and you're going to want the area to the left. For a positive one, you're going to have a positive t, and you're going to have the area to the right for a right tail. And this would be alpha, and this would represent alpha as well. For a two-tail test, you're going to have your two tails, the left side and the right side. This will be negative t, and you have your positive t. And this time, because you have two different regions, you're splitting the alpha in half. So this is half of alpha, and this is the other half of alpha. So if I want a level of significance of 10%, then this would be 5% and 5% for that. What else do you need to know? Same stuff that you've done before, except we're not going to make you guys do this algebraically. We're just going to use our graphing calculator. So if you have not grabbed that already, go ahead and grab that right now, because you're going to need it for later on in the notes. And then in words, for what we're doing, same chart or similar chart that we did when we had our z-scores and whatnot. For this one though, it's going to be a t-test. Same thing here. We're going to identify the null hypothesis and the alternative one. We're going to identify the alpha. The degrees of freedom is still n-1. You're just using a slightly different table for this one, and this is your formula. And instead of looking for z, you're looking for t. Same thing that you did before though, in terms of if it's in the shaded area, you're still going to reject. Not different for that. And then in addition to your graphing calculator, the only other thing that I would have you have is your t-chart. This is table 5, and it goes all the way down for a good little while, but at least up to 30 is what we're going to need today for later on. So if you can have that out, get it out, and it'll be a little bit easier for you to follow along. So for our first example, you're going to find the critical value or values and the rejection regions for the type of t-test with the level of significance that is given as alpha and for the given sample size. So we're looking for a right-tailed test. So if you're thinking about this graphically, you're looking for this part. It's a right tail, so you're looking for the positive version of t. And then your alpha for this is 0.01. Your degrees of freedom, remember, is is n-1. So for this case, it's going to be 30. df equals 30. And then from here, guys, you're going to use your chart, because what you need is what this value of t is, so that you can make a statement about that for the rejection region. So what you would do now is go to your chart, and then the degrees of freedom we said was 30. So there we go. I'm going to start at the very, very bottom of the screen so you can kind of use that as a line. And then what was my alpha? Well, for this one, we said that our alpha was 0.01. So you're going to go down to where it was 0.01, one-tailed alpha, then go all the way down, and then you will find that it should be 2.457. Right here, 2.457. So you go back to your notes. And the value of t is 2.457. So what's my rejection region? Well, we said that the rejection region is anything in this shaded area over there. So anytime t is going to be greater than 2.457, then in that case we would have to reject it. Number 2, speaking of rejection, State whether each standardized test statistic, T, allows you to reject the null hypothesis. Explain. So remember, the shaded areas are still my rejection area. So similar to what you did with the z-scores, you're just going to look at each value for t. So this is 1.705. And where would it be at in this number line? So positive 1.709, I'm sorry, 705. That's going to be before this. So this value is 1.725. It's going to be just a little bit before. So that means if it's in the not shaded region, it's fine. I'm going to fail to reject it. The null hypothesis, that is. Then for part B, I have negative 1.755. So negative 1.755 is going to be after this t value. So if it's after that, that means it's in the shaded region. Therefore, I will reject it. Take a moment, go ahead, press pause, and do C and D and check your answers with me. Alright, so checking, you should have a fail to reject for this one and a reject for this one because of where they lie on your graph. Alright, now, if you have your graphing calculator, great time to have that out and on and ready to go. Test the claim about the population mean mu at the level of significance alpha. Assume the population is normally distributed. If convenient, use technology. So now we get to use it. So we're going to. If you have your calculators, if you could please, we're going to enter the information that's important. So let's identify it first. So the mu is going to be 25 when they ask you. So actually, let's go to your buttons first. You're going to hit stat. And then you're going to hit stat, then the arrow to the right twice, and that gets you to the test category. You're going to hit number 2 for t-test, and then they're going to ask you, you want to enter data or you want to hit stats. And then just like we did for the previous day, you're going to make sure that you are in the stats area. So you're looking for S-T-A-T-S. Okay, and then they're asking you, first of all, what is the mean? And then on your calculator, it's asking you for, it's the not button right there. First thing they're asking you, so you're going to enter 25 for that one. And then they're going to enter in, what else do they tell you? Your sample size is 26.5. That's a given. The S on your calculator, though, is denoted as that. So that's going to be your 2.35. And your N is equal to 17. Now, for this one, your claim is an alternative hypothesis. Your null hypothesis would be what? Actually, it's this. Your null hypothesis, is less than or equal to 25 because it's the opposite of being greater than 25. So let's go ahead, type all of this information into your graphing calculator and then hit calculate instead of draw. But after you enter this in, sorry, I don't want to forget this part, make sure that you have selected the arrow that's pointing to the right for this one. Because remember, your calculator only understands the alternative hypothesis. So type that in, please, and then match your answer with mine. So I got 0.024 for mine, and so if I'm comparing the p and the alpha, my p is 0.024, and my alpha for this particular problem was 0.05. So my p is less than that. Therefore, I'm going to have to reject the null hypothesis, which therefore means that I support the alternative hypothesis. Why do I care about this? I care about me supporting this time because my claim is an alternative hypothesis. It's not a null hypothesis. So in your sentence, you would say, there is enough evidence at a 5% level of significance to support the claim. I don't have enough room to write that, but make sure that you know how to write that. There is enough evidence at a 5% level of significance to support the claim. All right, let's try another one. Talking about the IRS. The IRS claims that the mean wait time for callers during a recent tax filing season was at most 15 minutes. I don't believe it. A random sample of 40 callers, that's important. A sample of 40 callers, that sounds like you're in. Don't forget, this is your mean. Has a mean wait time. So this is with regards to your sample. So this is going to be your X bar is equal to 16.7, and a standard deviation, that's with regards to the population, is 2.7. Is there enough evidence to reject the claim at a 0.01 level of confidence or significance? So first thing we want to do is state the claim. The claim is that the mean wait time, so here's your claim. Mean wait time is, I don't know about this at most. I would kind of prefer to use symbols. So at most is the same thing as saying is less than or equal to. Or equal to 15 minutes. So they're saying the most that you're going to wait is 15 minutes. So what is your null hypothesis and what is your alternative hypothesis? So your null is going to be that the mean is less than or equal to 15. This is your claim. And your alternative is going to be that it is greater than 15 minutes. Use technology to find the p-value. So the same thing that we just did for the last one, I'm going to have you guys do right now. But let's just make sure that you are entering in the same information that I need you to. This is tragic. Which is what? Well, the n for this one we said was 40. The sample mean is 16.7. Standard deviation is 2.7. And when you enter that into your calculators, which I would love for you to do at this very, very moment, you can press pause if you'd like to and then unpause, you will find that the p is equal to 1.44 with some other numbers, e to the negative 4. Remember, that is scientific notation. And so you're going to move this over 1, 2, 3, 4 times. So really the p is 0.000144. And you're comparing that to the alpha. For this one, your alpha was 0.01. What is that? That is definitely less than 0.01. So I'm going to reject the null hypothesis. I'm going to reject it. So I reject the null hypothesis. This is their claim as well. So what are we saying then in a sentence? Because we're going to interpret that for part D. Well, we are saying that there is enough evidence. I want you to write all of this down because I'm doing it as well. There is enough evidence at a 1% level of significance. And remember that level of significance means there's like a 1% chance that I'm wrong. To reject the claim that the mean wait time is at most 15 minutes. Okay, I'm kind of overwriting this now. At most 15 minutes. All right, thanks. I bet you some of you guys fast forwarded as I was doing that. Here's your job. Your job is to press pause, like legit press pause, and try number 5 completely by yourself. Try number 5 all the way by yourself if you would, and if you could. Pretty please with the cherry on top. This is me stalling because right now you should be reading number 5, and then you're going to work it out. All right, check your work with my work. The claim given here, I identified H naught and the alternative hypothesis as well. This is the P that I got using technology, so if you didn't get this number, check with the neighbor and see why you did not. It's greater than or equal to that, so therefore I'm going to fail to reject the null hypothesis. And then your final sentence should be, there is enough evidence at the 5% level of significance to support the shop's claim that people travel more than 3,500 miles between oil changes. Thank you so much, and now begin your classwork.